All right, so for geometry, 2.7 proofs using angles. All right, so angles are congruent when they have equal measures. That seems simple enough, right? But we have a theorem to go with that. Okay, angle congruence is an equivalence relation. Okay, so angle congruence is an equivalence relation. We've talked about a few of those equivalence relations already. Then we have another theorem, the adjacent angle theorem. So if each of two adjacent angles is congruent to another angle in a second pair of adjacent angles, then the larger angles formed are congruent. All right, so here is a diagram, right? We've got a picture. These two angles, or like angle 3 and angle 1, are congruent to each other. You can see that by the little half moon right there. Angle 2 is congruent to angle 4. Okay, we can see that by the 2 marks. Now, the adjacent angle sum theorem, okay, says then the larger angles formed are congruent. So the larger angle formed here is angle ABC and angle PQR. So it's saying these angles are congruent with each other. Does that make sense? Lucas is saying yes. Landon is saying yes. We'll see. Don't just shake your head and say yes. Like if you're confused, I want to know because like you have to build off of these. So the proof for it is on page 89 if you want to see that, but it's saying given angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4. Okay, we can prove that angle ABC is congruent to angle PQR, which is what we just kind of showed you with the purplish red looking color. All right, then let's look at the next theorem that we've got. It's the adjacent angle portion theorem. Okay, so we look at that one. If two angles, one in each of two pairs of adjacent angles, are congruent, then the larger angles formed are also congruent. Then the other two angles are congruent. So what is this one saying that's different than the other one?
It's saying if the large angle and the tiny little angle are congruent to each other, then the medium angle is also congruent.
That's perfect. Okay, so if the large angles are congruent, okay, and then the tiny angles are congruent, then the medium angles, so angle 2 and angle 4, are congruent. They have to be. That's exactly what that's saying. Because sometimes you'll be given, like you are given different information about the problems all the time. And so you have to know, well, if these two are congruent, then I know that these two are congruent. Or this.
So if two of them are congruent, the third one's congruent.
That's a perfect way to look at it. Yep. If two of them are congruent, then all three of them are congruent. We just have different theorems that prove those. Good. All right, so then let's look at some classifications for angle pairs. Our first one is straight or a linear pair. Okay, because they make, why is it linear? What's the root? It's a line. Okay, the root word of linear is line. So it's a pair of adjacent angles that make a straight angle. So we have an example. 1 and 2 are a linear pair. Vertical angles, okay, are a pair of non-adjacent angles formed by two intersecting lines. So 3 and 5, or like 4 and 6 are vertical because they're opposite of each other. But 3 and 5 are also considered vertical. Okay, and they're congruent to each other. So it's a pair of non-adjacent. What does non-adjacent mean?
They're not adjacent.
They're not adjacent. What's another word for adjacent?
Beside each other.
Good, they are not beside each other. Very nice. And the next one, complementary angles are two angles with a sum of 90 degrees. Okay, so A and B, angle A and angle B are complementary because the measure of angle A, excuse me, equals plus the measure of angle B equals 90 degrees. So 38 degrees plus 52 degrees equals 90. So these two angles, if we put them together, would make a 90-degree angle or a right angle. okay, if we added them together. Questions so far? Okay, geometry, you remember, is really vocabulary heavy, right? Every day, it's like, okay, we're talking about more vocabulary and terminology.
English class 2 days, 2 hours in a row.
It is like having English class 2 hours in a row. All right, next angle pair, right, or classification is supplementary angles. These two angles sum to be 180 degrees. So this is review. We've done these, but we're laying it out for geometric purposes. Okay?
I guess we didn't need 2.7.
All right. So let's look at the next part. It says, recall what you can and cannot assume about figures.
What did it say?
So what can you assume?
What?
What can you assume about a drawing? This was from like last chapter, I believe. Maybe early in this chapter.
Assume, based on this picture,
Based on this picture, what can you assume?
2 lines.
Okay.
Perpendicular.
You cannot assume perpendicular, actually. Okay, so we cannot. Oh, okay. So let's go there. So we can't assume that they're intersecting. That's good. We cannot assume perpendicular. So
Assume that they're all right angles.
No, you can't. Because if you can't assume that they're perpendicular, you can't assume that they're right angles.
good. So that's a good point. We can't
There's
assume.
2 lines.
There's 2 lines. Okay. We know that there's 2 lines. But that was a good point. We can't assume that they're perpendicular, but we also can't assume that they're 90-degree angles. Those are the same thing.
So no measurements, basically.
No measurements. Good. No measurements.
If there's 4 angles.
Okay, we can assume that there's 4 angles.
Lines
That's
go on forever.
well, we said there are 2 lines. We know that lines go on forever. How about U, V, and W?
V's a midpoint.
We cannot assume that V is a midpoint.
Oh, because that's a measurement.
Mm-hmm.
Um,
What can we assume about U, V, and W?
they're all in 1 line.
They're all in 1 line, so we can say they're collinear.
Oh, and V's a intersecting point.
Okay, so let's see. U, V, W are collinear.
And then X, B, Y.
So we have intersecting. So what did you say there about V being an
V is the intersected point.
Okay, so V intersected, or point of intersection, or whatever. So intersected point. What about betweenness?
What do you mean?
Like that V comes between U and W.
Because it's right there in between.
Right, but that's one that we can talk about too. We had betweenness. So it was like U and then V's in the middle and then W. We can assume like, or we could say the same thing about X, V, and Y. Right? You brought up a good point about the midpoint. We cannot assume midpoint. I didn't get that written on there earlier. Which is like saying we also can't assume, we can't assume that UV equals UW. Or VW, pardon me. Because that goes along with that same thing about the midpoint. Can we assume any angle pairs?
No. Yeah, you could.
Not congruent pairs, but angle pairs. Like we just talked. So the first one was a linear pair, right? Are any of the angles linear?
Yeah.
What?
Angle YVW and angle.
Can you give me the numbers? So we have.
But there's not a number on one of them.
Okay, so pick a set that do have numbers.
8 and 7.
Okay, 7 and 8 is a linear pair. So angle 7 and angle 8 are linear. Is a linear pair. What's another example of a linear pair?
9 and 7.
9 and 7, okay, because they make a straight line. How about any vertical angles?
Yeah.
Which ones?
Angle 8 and angle 9.
Angle 8 and angle 9 are vertical. We can't assume that. So angle 8 and angle 9 form a vertical pair. Lucas, are we following? Okay. Landon, how are you doing? Are you sure?
No, seriously.
Okay.
7 and 8.
Do we have any complementary angles?
7 and 8.
7 and 8 form a 90.
Supplementary angles are 7 and 8.
Ooh, 7 and 8 could be supplementary. Okay. So angle 7 and angle 8 can be supplementary. Because they form a straight line. So here's the thing. If the angles are a linear pair, are they also supplementary?
Yes.
Yeah, right? If they're forming a straight line, then they have to also equal 180.
Oh, because it has to be straight.
Yes,
No.
it's kind of redundant.
I guess it. Yeah.
Okay. I like it. I like that you thought through it, though. Kind of argued with yourself a little bit.
Well, if it goes like this, and then I'm like, well, technically that's.
You're good. I like it. All right, so then we have the linear pair theorem. Lots of theorems coming up. The linear pair theorem. Angles that form a linear pair are supplementary. Like, promise I didn't just have that comment to connect those, but
You definitely did.
we definitely did. All right, so that's the linear pair theorem, right? If they're a linear pair, then they're also supplementary. Let's clean the board and move it up so we can look at the rest of them kind of together. All right, so the next theorem. If two angles are adjacent and supplementary, then they form a linear pair. So now we're working backwards. Okay, if we know that they're adjacent and supplementary, we can call them a linear pair. The vertical angle theorem. Vertical angles are congruent. Okay, so if we have an intersection like this, what is angle 4 congruent to?
6.
6, because it's the vertical. What's angle 3 congruent to?
5.
5. All right, because they're vertical. So vertical angles are congruent. The next theorem, supplements of congruent angles are congruent.
What are supplements?
Okay, supplements of congruent angles are congruent.
What are supplements?
Hold on. I feel like okay, so Cameron, you asked what supplements are. So supplements, sorry. Thank you. Caden, I'm so sorry. I do it all the time. I'm gonna have to like start bringing you candy. All right. So supplements of congruent angles are congruent. And so Caden asked, what are supplements? So if we have, like, say we have this, and so we know this angle is congruent to this angle over here. So let's say this is angle J, and this is angle K. All right. So the supplements of those would be the other part. So those would have to be congruent as well. Does that make sense? And then the supplements of the same angle are congruent. A corollary is a statement that follows immediately after another, or from another theorem. So we're going to get into some more of those, but it's kind of like the backwards of the theorem. It follows usually right after. All right, on to your second sheet. We've got some proofs and helpful strategies. All right, so the first thing is diagrams. The second one, apply the definitions in previously proved theorems. Okay, so we talked about these some already, but we're going through those helpful strategies to get them ingrained. The next one, use similar proofs as examples. So feel free to look back at proofs we've already done in class, in our notes. There are a lot in the book that I don't copy down in your notes. You can use those, but a lot of times I will put the page number where you can find the proof. So you could go back and look at it to see if you can get some help. Reason backwards from the conclusion. And the last one, if proving the converse, try reversing the reasoning done in the previous proof. So if you had to do one proof and then it says now prove the converse, we'll try to reverse it. And then there's a whole bunch of more theorems here. Okay, so each of these is a theorem. So the first one is the complements of congruent angles are congruent. Okay, so complements equal, what degree angle is a complement? Complementary angles equal, not the opposite. Right, we have the supplementary angles pairs and we have complementary angle pairs. How many degrees are complementary angles?
Sum of 90.
90. Okay, so the complements of congruent angles are congruent. So if we have a 90-degree angle, right?
Yeah.
And this one is congruent to
No one's home.
this one, okay, and we know that this is a 90-degree angle, then we know these two are also congruent.
True.
All right, the next one, all right angles are congruent. Well, duh, because they're all 90 degrees. The next theorem, congruent supplementary angles are right angles. So if we have a straight line, right, they're supplementary angles, and this angle is congruent to this angle, you know that they have to be right angles, right? You know that they both have to be 90 for them to be congruent and some to be 180 degrees. Are we good? So much information. It's like information overload. All right, if one angle, the last one, if one angle of a linear pair is a right angle, then the other angle is also a right angle. So that's kind of like this one, but it's different. It's if you're given this information, then you can figure out, well, how big is angle 2?
90 degrees.
90 degrees, because angle 1 was 90 degrees. Okay. All right, so on your own, I want you to try these and see what you've got before you start on your homework today. Okay, let's actually look at the on your own because, got some complaints here about having to do a proof, but so let's try it together. All right angles are congruent. So this is number 32 in your homework, actually. So if you're given angle A and angle B are right angles, what do you need to prove? Wait, that they are congruent. Yes. So you want to prove that angle A is congruent to angle B. Very nice.
Like I knew that part.
Okay, Lucas, what's statement 1?
Oh, I remember these now.
Angle A and angle B are right angles.
Good. Are right angles.
Maybe it won't.
Okay, because remember this is the given, and so it told us our reason was given, so we just bring it right down into statement 1. Okay. So then statement 2, the reason is the definition of right angles.
90 degrees.
Yeah, it's 90 degrees. So the measure of angle A equals 90 degrees. And I'm going to put the measure of angle B equals 90 degrees. Because that's the definition of a right angle. The angle is 90 degrees. All right, so then I gave you statement 3, the measure of angle A equals the measure of angle B. What's the reason for that? What property could we use? Remember we had like reflexive, symmetric, transitive.
No.
Would not be the reflexive, because reflexive, where are you looking in your notes? Where are you, Caden?
2.6.
2.6. Okay. Addition and multiplication properties we have. The equivalence relation, the substitution property. There's 2 of them I would take. So what if we reconsidered this as, like, look at this one. So we have if A equals B and C equals B, then there's a couple different ways we could look at that one. We could call it the transitive property, right? Because then A, right, then A equals C. All right. So that one could be the transitive property. That's a terrible color. I thought I was making it better when I changed it. So you could call it the transitive property, or what other thing could you call it maybe?
We could call it the
Not the symmetric, because that says if A equals B, then B equals A.
multiplication.
The substitution. You don't agree with substitution?
Because I can't find it.
It's down below. So it says equivalence, and then at the
A
very
plus
bottom,
B,
substitution.
A can replace B in any mathematical statement.
So we're replacing the 90 with this one. So transitive property or substitution, I would take. Okay, the substitution property. All right, then how about that last one? Then we say, well, okay, angle A is congruent to angle B.
Hey, conclusion.
Ha! I know. You told me that last time. I like it.
Every single time.
Every single time. It's a definition. What is that a definition of?
Definition.
Uh-huh.
It's not any of these. Not the property.
It's not any of the properties. This one is a definition. I'll help you out with that much.
Oh wait, no, wait, oh wait, no, wait.
So we took this information. We know that measure of angle 1 equals the measure of angle 2, and we can make this conclusion because we know the definition of.
One sec. We have none of angle ones? We didn't do any angle ones? You sure?
Definitions? Not in today's.
No, I'm looking throughout because I thought we did an angle one of these already. Guess not. The angle definition.
What kind of angle definition?
The equivalent, no, congruent angle definition.
The definition of congruent angles. That's exactly it. Okay, so I'm going to start using more shorthand in these as well. So like angles will always be the angle sign with like an S inside of it, just so you know. So some of those
Well,
you'll.
or you can simplify it just by saying conclusion.
I could simplify by saying conclusion, but it wouldn't make it better for you in the long run, I promise. All right, so now I'll let you get started on your homework though.